Dear my friends, today we will discuss on the topic of agitator trip velocity. Are you aware about it? The answer is yes. This is the commonly term used in the industry. But many times we are only aware about the formula or you just have heard this term, but the actual application is missing. So in this video, you are getting the idea about agitator tip velocity. You can get about when it to be used and when it not to be used. Only the knowing the formula or the scientific information is not enough in the industry. It may work in the academics, but in industry it will not work as it is a practical field. So you should aware about its application, when it to be used, when it not to be used. So for the more information and to elaborate this concept, we can go to a website called the pharmamaster.com. In that, you have to go to the page technology, and in that you have to go to the batch reactor. So this will help us to know the concept. Now, okay. So batch reactor. Okay, sorry, it will take some time. Okay, just wait for some time. Okay, so this is the batch reactor. Now, see what is the tip velocity. So first of all, we should know what is the tip. Look at this agitator. It is the anchor agitator. Everybody knows. So this part is called as a tip. This is the propeller agitator, where this part is called as a tip. Means here are two tips are there in the anchor. This is the 6-blade turbine, where this one is the tip. Means here are 6 tips. This is the MIG. Here also 3 tips are there. So this is about the tip velocity. Now, if you are transferring any reaction or any extraction application from one reactor to another reactor, then in that case the tip velocity we need to calculate. But if see the tip velocity calculated for this type of agitator, will work for this one? And answer is no. Reason being, the geometry is different. So it will not work the tip velocity for anchor to the propeller, and propeller tip velocity calculation will help for the turbine. Then you should have to always keep in mind that for the similar type of agitator, you have to calculate the tip velocity. For the different type of agitator, this formula will give you the answer, but it is not valid. You are not getting a result on a practical sense. Now, coming to the formula. See, this is the formula of a tip velocity pi dn, where d is the diameter of a agitator, n is the rotational speed in second. So we'll take one example. for your understanding. Reactor with capacity 5 kL, agitator is running with at a 75 rpm. 5 kL reactor and its agitator running at 75 rpm. Agitator sweep diameter is 1.2 meter, and in this case we have to calculate the tip velocity. Now what is the given? Given is a 75 rpm, so we have to convert it into the rps. How it is converted? 75 divided by 60. It will gives result in the rps, that will be 1.25. You can calculate as well. Agitator diameter is 1200 mm. Now it has to be converted into meter, so divided by 1000, so it will give the answer 1.2 meter. Now the formula is pi dn, so pi is 3.14, d is 1.2, and n is the 1.25, so it will give the answer 4.71 meter per second. But you should have to always keep in mind, for the same agitator, T velocity will be taken into account. For the different agitator, you don't match the T velocity, you are not getting any result. You can, on paper you can match, but on the practical ground you may definitely fail. So this is all about the T velocity calculation. Thank you.